All right, so here is our reviewed lecture for quiz 6. First up, I'm having you graph a quadratic function and an inequality. Make sure to include at least 5 points. So this first one is presented in standard form, right? Ax squared plus bx plus c. So in order to get to my vertex, I need to do negative b over 2a. So I'm plugging in a negative 1 times a negative 4 over 2 times a negative 1. And 4 over negative 2 is negative 2. So the x-coordinate of my vertex is at negative 2. I need to plug back in to get to the y value. So y equals negative 1 times negative 2 squared minus 4 times negative 2 minus 4. So following my order of operations, a negative 1 times 4 is negative 4 plus 8 minus 4 goes to 0. So my vertex is at negative 2, 0. And since I see a negative 1 out in front, there's also a vertical flip. So I plot my point, my vertex at negative 2, 0 right there. Right, it's going to bounce off that x-axis, and then over 1, down 1, over 2 and down 4 because of that vertical flip. There are my 5 points. There is my quadratic function. Okay, next one over here, little different because it's an inequality sign right here instead. Right, it's saying greater than. So here it's presented to me in factored form, in intercept form. So I should be able to see that my x-intercepts are at negative 3, 0 and negative 5, 0. And if I plot those right here, I know that right smack in the middle is my axis of symmetry and the x value of my vertex. I can confirm that by averaging those two x-intercepts. So I'm adding the negative 3 and the negative 5, right? So negative 3 plus a negative 5 dividing by 2 is going to get me negative 8 over 2, negative 4. So the x value of my vertex is at negative 4. Plug back in to find the y. So negative 1/2, negative 4 plus 3, negative 4 plus 5. So now negative 1/2 of negative 1 times positive 1 is going to get me 1/2. So my vertex is at negative 4, 1/2. I can see that there's a negative out in front, so there's a vertical flip. And that 1/2 is a vertical shrink by 1/2. So when I plot that negative 4, 1/2 right here, that actually makes sense. Because from that vertex, I'd be going over 1 and down half of 1. So right there. Over 2, down half of 4. So here's 1, 2, right? So down 2, that's half of 4. If I went over 3, I'd be going over half of 9. So down 4.5. So 1, 2, 3, 4, and 1/2 right there. I'm giving you more than 5 points, but that's fine. We like to be precise. Okay, I'm graphing the quadratic dotted because it's saying greater than, not equal to. So that part is dotted. And if I go to where the vertex is, the fact that it says greater than, I'm going to shade in that above and all around region. I can also double check by plugging in the origin. Right, if I plug in 0, 0, for example, let's say I put my check right here. 0 greater than, okay, over here I would have negative 1/2 of 3 times 5. Is 0 greater than negative 15 halves or 7.5, right? Negative 7.5. Well, yes, absolutely, that's true. So that just verifies that the origin right here is in my solution region. So I'm just shading this whole region. Any point that falls in this shaded region is part of my solution. It would make this statement right here true. All right, next up, we're doing a bunch of factoring. I'm trying to emphasize the new style of factoring. First up right here, when I look at my two terms, I want to start to think, is this a difference of two squares or two cubes? Because we've seen that as an option. And I recognize these as perfect squares. Right? This is 4x squared to the second power, and this is 1 to the second power. So a difference of two squares. It breaks into 4x squared minus 1 times 4x squared plus 1. But when I stare at it, I notice that right over here, this is still a difference of two squares. This is 2x in parentheses squared. This is 1 squared. So one more layer, 2x minus 1 times 2x plus 1. There is no sum of two squares. There's nothing else to do here. This stays put as 4x squared plus 1. So this one was essentially a difference of two squares twice. All right, the next one here, there's no GCF, and I recognize that these are both perfect cubes, and there's a minus joining them in the middle. So 3 cubed is 27, and x to the second power cubed is x to the sixth power. So I'm just looking at it as, what is it that's being cubed first? Okay, 125 is 5 cubed. All right, so then building out the structure, I take the 3x squared and the 5, and then I take the 3x squared, that whole package, as a quantity squared. So 3 squared and x to the second power squared gets me 9x to the fourth. Okay, product between these two terms, so 15x squared, and then the 5 squared is 25. Now I need to put in my signs. So think of soap. So same sign, right? So a minus here, opposite sign. So that minus here means I'll have a plus here. And then the AP is always positive right there. Okay, this is fully factored. There's nothing else for me to do. All right, so that one was a difference of cubes. Okay, this last one, what I see is that there's no GCF. Here I have an x to the sixth power, x to the third power, right? That power is half of what that first one was, and then my constant. So this one is quadratic-like. The most common one we see is a power of 4, power of 2, constant. But even a power of 10, power of 5, constant would be quadratic-like. So in the first positions, I would have an x to the third power and a 2x to the third power. So that's what's multiplying to get me that 2x to the sixth power. So that x to the sixth has to come from an x to the third times an x to a third, but since there's a 2, one of them has to have the 2 out in front. So now I'm looking at that 12, and I'm thinking of all the ways I can get to 12, right? I know that could be 1 and 12, 2 and 6, or 3 and 4. And I'm trying to picture what is it from the outer and the inner parts, those products, that will get me that negative 5x to the third. So if I think about it for a moment, it should land that it has to be putting my 4 right here and my 3 right here. Now, one of them has to be a negative, one has to be a positive. And right now, I'm seeing that I have a 3x to the third. And here's an 8x to the third. So if I want this to be a minus 5x to the third in the middle, it must be the 8x to the third, that's the negative, which means that my negative must go here and my positive must go here. So if I double check it, right here, that first multiplies back to the 2x to the 6th. The outer and the inner get me that minus 5x to the third, and that minus 4 and positive 3 gets me that negative 12 right here. So I am good, fully factored. All right, next I'm having you find the discriminant and determine the number of solutions. So the number and type of solutions. Then we'll solve it, and then we'll simplify our radicals, if we have any radicals. All right, so first off, I need my equation to be set equal to 0. So I'm going to add the 5 over. All right, looks good. So now to find the discriminant, it's the part that's under that square root in the quadratic formula. So I'm looking at b squared minus 4ac, and I'm paying attention to what the sign is. If it's positive, I'll have 2 real solutions. If it's 0, I have 1 real solution. And if it's negative, I'll have 0 real solutions because I'll have 2 imaginary solutions. So when I plug in, I have 4 squared minus 4 times 5 times 5. So 16 minus 100 is a negative 84. So that's the value of my discriminant, and that tells me that I have 0 real solutions or 2 imaginary solutions. So if I was graphing this as a function, so y equals 5x squared plus 4x plus 5, that just means it wouldn't cross the x-axis at all. So now if I find them, I'm just plugging into quadratic formula. So x equals negative b, so negative 4 plus or minus the square root. We already know what b squared minus 4ac is. That's negative 84 all over 2a, so 2 times 5. So now it's resolving what is the square root of negative 84. I know that there's going to be an I because there's a negative under my root. So if I simplify the square root of 84, that's 4 times 21, so 2 root 21. But since there was a negative, 2i root 21. All over 10. And if I'm going to reduce this, I'm looking for a number that goes into each of these 3 parts. They are all divisible by 2. So my final answer would be that x equals negative 2 plus or minus I root 21 all over 5. Right, those are 2 imaginary solutions. Okay, next up, I'm having you solve each polynomial equation. First one is more basic because really this one's just a quadratic. I see an x to the 2nd power. I anticipate having 2 solutions. So I want to get that squared by itself. I'll subtract the 2. All right, so 2/3 of the quantity of x plus 5 squared equals negative 12. If I want to clear my fraction, I can multiply both sides by the reciprocal, right, of 2/3, which is 3/2. Multiplying a number by its reciprocal clears to 1. So now I have x plus 5 in parentheses squared equals negative 18. All right, so now that I'm here, now I can solve by taking the square root. X plus 5 equals plus or minus. Okay, so I know it's going to be an I again. 18 is 9 times 2, so 3I root 2, and then take away the 5. So negative 5 plus or minus 3I root 2. So 2 solutions right there. Okay, next one here, I'm giving you x to the third power plus 64. Okay, I recognize that as a sum of cubes. I can see that this part right here is x cubed and 4 cubed. So if I factor this down, I have the x and the 4. The x gets squared. The product of the 2 in the middle, 4x. The 4 gets squared, 16 right here. Okay, then the SOAP, same sign, opposite sign, always positive. All right, that's as factored as I'm going to get. And here I see that I have one solution here at x equals negative 4. But I have 2 more solutions, so it just depends on how I want to solve this. I could solve this by using quadratic formula again, or I can complete the square. So to give you variety, I'm going to complete the square. Okay, I'm going to move that 16 to the other side by subtracting it over. So here's my equation right now. So now I want to look at that linear term. I want to split it. Gets me negative 2. Square it. Gets me 4. So again, I've just completed the square. So now on the left side, I have x squared minus 4x plus 4. But I have to balance it on the other side. So add 4 to the other side as well. The whole point of doing that is that this is a perfect square trinomial. It factors into a binomial squared. X minus 2 times x minus 2. So x minus 2 as a quantity squared is equal to negative 12. So now I can solve by taking the square root. So x minus 2 equals plus or minus. Okay, I know I is going to show up again. Lots of practice with I today. So 12, I know that that's 4 and 3. So I will have plus or minus 2I root 3. And then I add the 2 to the other side. All right, so 2 plus or minus 2I root 3. All right, next one, I'm just circling back to this problem that was on one of the versions on the last quiz, quiz 4. So here I wanted to return to quadratic modeling. So we're told that we have the height of an object above ground, and here's our equation for it. Time is measured in seconds, height is measured in meters. So can you find these 2 things? And sometimes it helps to have a visual of what it is you're solving for. So if I make myself a little picture, here we know that this is the starting height of the object. So wherever I am on the y-axis, right, that's my y-intercept. My object goes up and it comes back down. So right here is the 58.5 or 58.8. Let me make sure I read that right. 58.8. Okay, and then here the x-axis is the time in seconds and the y-axis is the height. So what I'm having you solve for here is, well, when does the object hit the ground? Okay, and it hits the ground when the height is 0. Okay, so then if I go back to my equation, I'm looking for where the height here is 0. So I'm going to put a 0 in here, and then I'm going to look at what my equation on the right should look like, right? So 0 equals negative 4.9 t squared plus 19.6 t plus 58.8. Now, plenty kids will just take this straight to the quadratic formula. We see that with a lot of these modeling problems. Sometimes that's easy to do. This one actually factors. So if I divide out a GCF of negative 4.9, here I have just t squared by itself. 19.6 divided by negative 4.9 is actually just minus 4 and then t. And then that 58.8 divided by negative 4.9, I get minus 12 right there. So I see that, oh, I can factor that more. What multiplies to a negative 12 that adds to a negative 4. So here's that GCF, and then t minus 6, and then t plus 2. So I could have a solution where time is 6 seconds, or where time is negative 2 seconds, right? So here's the 6, the negative 2 would have been over here. Can't go back in time. That's an extraneous solution, so I'm going to cross it out. The solution that I'm looking for is 6 seconds. Right? So as a point right here, this would be 6, 0. At 6 seconds, the height is 0. Okay, then I'm asking for the maximum height. Well, the maximum height is right here. Right, I'm really looking at the vertex. So I need to know how long it takes to get to that maximum height. So when I get to my vertex, we're used to doing x equals negative b over 2a, but here we're talking about time. So time is negative b over 2a. So if I plug in, I'm looking at negative 19.6 over 2 times negative 4.9. Negative 19.6 over negative 9.8 gets me just 2. So it takes 2 seconds to get to that maximum height. I just need to know what that is. So I'm looking at my height at 2 seconds. So h of 2, negative 4.9 times 2 squared plus 19.6 times 2 plus 58.8. So negative 4.9 times 4, negative 19.6. Okay, 19.6 times 2 is 39.2, and then add 58.8. So when I add these together, I get 19.6 plus 58.8, and I land at 78.4 meters. All right, these are the two most common variations of those modeling problems. Okay, flip to the back. Okay, a reminder about quadratic inequalities. So here, always look for a GCF, right? I see a GCF of negative 2, so I'm going to divide that out, leaving behind an x squared plus x minus 72, less than 0. Here, what multiplies to a negative 72 that adds to 1? Should see that that's going to be x plus 9 and x minus 8. So now I'm fully factored. So if I'm visualizing a sketch of this as a function, these are my x-intercepts. I'll have one where x equals negative 9 and one where x equals 8. Again, if I'm graphing this as a function, right, I would have a flip to it, vertical flip, and a vertical stretch of 2. But my intercepts, my x-intercepts are staying put regardless of the flip or the stretch. So if I plot those kind of loosely, here's negative 9, here's positive 8, I'm looking at a quadratic function that would open down, right? Again, because of the negative. So then if I'm trying to think about, well, where is my function equal to 0? Well, that's right here. These are the two locations where my function equals 0. And then I'm looking at, well, where is it less than 0? So here's where the y values would be negative, and here's where they would be positive. Less than 0, more than 0. I want less than 0. So I'm looking at this region right in here. And since it was less than not equal to, I'm leaving these guys hollow. Sometimes we like to see it on just a number line. So if you like to visualize it that way, that's okay too. It's not necessary. I'm just giving you another way of looking at it. So when you write your solution, you're saying, okay, anything from negative infinity to negative 9, union with 8 to infinity. So anything in this span or this span will make this statement true. Okay, next up is the process of completing the square to write an equation of a circle in standard form. So I'm going to first just reshuffle it, put my x's next to each other, my y's next to each other, and then the constant on the other side. So x squared minus 10x, y squared plus 4y, add the 1 over, it's now on the other side. So I complete the square for the linear term for the x's, take that negative 10, split it in half, square it, we get 25. Same thing for the y's, split it in half, square it, we're back to 4. So now on the left, we have x squared minus 10x plus 25 plus y squared plus 4y plus 4 equals 1 plus. Can't just add 25 to the left. I got to balance it on the right. And same with the 4 right there. So now this is a perfect square trinomial. So is this. So when I factor this, this becomes x minus 5 quantity squared, y plus 2 quantity squared, all equal to 30. Okay, and I'm not making you graph it, but now it is graphable. My center would be at 5, negative 2. This is my radius squared, so my radius would be the square root of 30, right? So somewhere between 5 and 6, somewhere in the middle, roughly. Okay, next is practicing our divisions. So long division, synthetic division. So if I start with long division, this is what I'm dividing out. So I have x squared plus 3x plus 1. And I'm dividing it out of this. Now I don't have a cubic term, so I got to hold its spot with a 0. So I have 2x to the 4th plus 0x to the 3rd plus x squared minus 3x plus 6. So I'm dividing out a trinomial 3 terms. So I like to open my parentheses 3 wide and just show that I'm getting ready to subtract. So x squared times what is 2x to the 4th, right? It's got to be 2x squared. So now if I multiply that back, that's 2x to the 4th here plus 6x to the 3rd plus 2x squared. So here these are opposites, those 0 out. 0x to the 3rd minus 6x to the 3rd is a minus 6x to the 3rd. 1x squared minus 2x squared is minus x squared. Bring down the next term. Build out your structure. Okay, so let me see if we look good. Everything looks good. Okay, so now as I'm working through it, now I need to look for x squared times what is negative 6x to the 3rd. So here I can see that that's going to be negative 6x. Okay, and then I multiply that back. So here I see negative 6x to the 3rd minus 18x squared minus 6x. Okay, so negative 6x to the 3rd minus negative 6x to the 3rd zeroes out. Negative x to the 2nd minus a negative 18x squared, so that reads as a plus. And then negative 3x minus negative 6x is plus 3x. Bring down that last term. Okay, so let's see where we're at right now. Build the structure. Okay, so x squared times what is 17x squared? So plus 17. Okay, if I multiply that back, here's my 17x squared plus 51x plus 17. Okay, so these zero out. 3x minus 51x is a negative 48x, and 6 minus 17 is minus 11. And that's my remainder. So when I write my answer, I'm going to say that I have this whole chunk here, 2x squared minus 6x plus 17, plus, right here, negative 48x minus 11 divided by x squared plus 3x plus 1. Ha! I see that I transferred that wrong. So why don't we make it that a plus 1? I'll change it on your version too because I just transferred that wrong. Right, so we just divided out x squared plus 3x plus 1. So I'll change it on your version too, but that's what I divided out. This would have your remainder right here, and then here is what your divisor was, what you were dividing out initially. All right, so this would be our answer if we were taking this polynomial and dividing out right here that trinomial. All right, one more. Okay, synthetic division. So here's synthetic. If this is a factor, then I'm dividing out x equals negative 3. Now again, I have to have a little placeholder for my quadratic and my linear terms. So 2, 0, 0, and then 6. Make sure I transferred everything right. It looks good. So now I start by bringing down a 2, multiplying, adding down, multiplying, adding down, multiplying, okay, adding down. That right there is my remainder. So this is here my constant, my linear, my quadratic terms. So 2x squared minus 6x plus 18 plus negative 48 divided by x plus 3. All right, some graphing ones. These should go fast. So here I'm saying let's factor and then graph in intercept factored form. Label all x-intercepts and the y-intercept too. So this first one, I noticed that I have a GCF because there's a negative 1 out in front. I'm going to divide that out first. Okay, don't forget we divided it out. So now I see that I have a cubic polynomial that I can only factor by grouping. So I want to group the first two and the last two like that. And I can see that a GCF here is x squared, leaving behind an x minus 3. Here my GCF is minus 4, leaving behind an x minus 3. These match as they have to. So now what I have is that negative 1 times x squared minus 4 times x minus 3. Okay, one more step to make it fully factored. Negative 1 times x minus 2 times x plus 2 times x minus 3. So I should be able to see that my x-intercepts are at 2, 0, negative 2, 0, and 3, 0. So about here, here, and here. Okay, in my y-intercept, I can always see from my standard form equation here, because if I plug in a 0 for x, all of that knocks away, and I'm just left with the negative 12. So 0, negative 12. So somewhere down here. Okay, it's negative and cubic, so odd. So I start high, I end low. So start high, end low. So I can start high, and cross through like this, up, and then down like that, and then mark this as negative 12. So again, this was cubic, negative, odd. So start high, end low. I just want to see all those places labeled. Okay, last one. This one looks like it's quadratic-like. So it should be x squared and x squared in those first two spots. I need something that multiplies to a positive 400 that adds to a negative 41. So here I could see that that's going to be 16 and 25. Both have to be minuses to make that positive 400 and add to the negative 41. Keep going. So x minus 4 times x plus 4. X minus 5 times x plus 5. So then I know that my x-intercepts are at 4, 0, negative 4, 0, 5, 0, negative 5, 0. Okay, and my y-intercept, if I plug in a 0 for x, it's just 400. So 0, 400. Okay, plot those points just roughly. Okay, it's positive and quartic, so even. So just like a quadratic that opens up, right? I'm going to go up, up, right? Rises, rises. So I start high, turn, come up, turn again, come back up. Label those intercepts. Okay, so again, positive, even, rises, rises. All right, have a good rest of your day.